DNP3 Basics, Lesson 5, Transport Layer. This should be a very short lesson because the transport layer is only one octet. How much can be said about one octet? The transport layer used to be called a layer, but is now called the transport function, a sublayer of the application layer. It consists of a single octet called the transport header. Whatever it is, I will explain it in this lesson. It kind of reminds me of a town I used to drive through in Indiana. The town was Monroe. It had a sign welcoming people to the town and a sign indicating you were leaving. It was the same sign. To start the discussion, I am repeating a diagram from the second lesson. The transport is that little square at the left of each frame. The transport, whatever it is the first octet after the data link layer. Its only purpose is to allow reconstruction of application messages that are larger than one frame. Remember, a frame is limited to 249 application octets, and an application fragment may have as many as 2048 octets. The transport function begins and ends with the transport header octet, consisting of a fin flag, a fur flag, and a 6-bit sequence number. The fur bit, when set, indicates that this is the first frame in an application message. The fin bit, when set, indicates that this is the final frame in an application message. When all application data fits into a single frame, both fin and fur are set. When multiple frames are required, fur is set only in the first frame and fin is set only in the final frame. The sequence number can be any value in a frame with fur set, not needing to correlate with any prior message. When fur is not set, its value must be one higher than the preceding frame. It wraps to 0 if the sequence number in the preceding frame was the largest 6-bit value, or 63. Note again that there is no correlation between the final sequence number for one message sequence when fin is set and the first sequence number in the next message sequence when fur is set. It is okay to continue numbering. It is okay to start each sequence at 0. It is okay to start each sequence with a random number. The only requirement is increasing sequence numbers when fur is not set. Why is the sequence number required? The sequence number is required for noisy serial lines when one message might be lost due to CRC errors. It is also useful in some rare UDP implementations when delivery is not guaranteed, and possibly, but rarely, one or more messages might arrive out of sequence. There is no requirement in DNP3 to analyze and reassemble messages that are received out of order. Normally, a bad sequence number causes the receiving station to discard the entire application message. The receiving station must be the master, since masters cannot send fragments that are longer than one frame. Here is an example of an application fragment sent in 2 frames. The first frame has a large amount of data. The second frame has the smaller leftover octets. The 2 colors show a combination of data from the 2 frames into a single fragment. Okay, that was a short lesson. What did we learn? The transport function is used to combine parts of an application message sent over two or more data link frames. Sequence numbers are only meaningful for multi-frame messages, and the transport header is similar to Monroe, Indiana.